Assalamualaikum, this is Abu Bakr Ali, and today we are going to discuss about the impulse. Impulse is basically it's a subtopic of momentum. So let's see what the impulse is basically. So how we can define it? In physics, impulse is the product of the force applied to an object and the time over which the force will act on it. Okay, so if we want to write its mathematical form, we can say that impulse is basically product of force and the time duration, and you can also write as f into delta t. So that is impulse. It is usually represented by a symbol j. Okay, so in nature it is vector quantity. So impulse have direction, right? So impulse act in the direction of force, and the units of impulse are Newton second, or it can also be kg meter per second, right? Okay, impulse can also be defined as, there is another definition for the impulse is change in momentum. Change in momentum. But how and why we can say that the impulse is equals to change in momentum? Let's see. So from the Newton's second law, we know that F is equals to ma, right? Where F is the resultant force, m is the mass, a is the acceleration that is acting, and acceleration we have defined previously as a is equals to v minus u. V is the final velocity, u is the initial velocity divided by time. So if I put this value of acceleration here, what I will get f is equals to m, and I am going to put the value of acceleration, that is v minus u divided by t. So this whole thing will turn into, when I open the bracket, it will be mv minus mu divided by t. Okay, so mv, what it is? Mv is basically final momentum. As we know, momentum is a product of mass and velocity. Mu will be the initial momentum. So when we find the difference of initial and final momentum, what we will get? Change in momentum, right? So mv minus mu can be written as delta p. That delta p shows the change in momentum divided by time. So that is the relation for the force, right? So force can be defined as rate of change of momentum, right? Okay, so this relation is very important. This is another form of Newton's second law. One form was that F is equals to ma, and one form we have in term of momentum. Now if I write it like F, this t can go on the left side and it will be multiplied by the F, right? So if we write in that form, F multiplied by t, that will be equals to delta p. And we know that already this F and delta t, they are equals to impulse that we have defined above, right? So that is impulse and that is change in momentum. So we can say that impulse is equals to delta p. So here we have another very important relation, that impulse can be written as F into t, that can be written as delta p. So they are equal to each other, right? Okay, so that is the definition, the mathematical form, the units and the nature, right? So what are the application of it? हम इसे और बेहतर तरह से कैसे अंडरस्टैंड कर सकते हैं कि हाउ द इम्पल्स विल एक्ट इन द डेली लाइफ, हम इससे रिलेट कैसे करेंगे, कहाँ पे यूज़ होगा? ओके, देयर आर मैनी एप्लीकेशंस ऑफ इट, and before moving forward, make sure you will subscribe and enable the notification so you will get the next videos. Next video I'm going to upload will be on the problem solving. We will try to solve some past paper questions related to momentum and the impulse. Okay, so make sure you are you already subscribe here and like and on the notifications on this channel. Okay. Okay, so what the impulse is in the daily life? Impulse is in the daily life is basically it's the product of force and the time. If someone punch you right in the face, I hope this will not happen with you. So wise decision क्या है? You should not remain there. बल्कि आप क्या करो? It's better to ride the punch in the same direction. Move your face in the direction the punch is coming, right? So it will increase the time of impact or the time of what we can say the contact between the punch and the face. The time will increase, that will decrease the force, right? So how it can decrease the force if the time is increasing? Basically, impulse is a product of force and time, right? What was the time? Time of contact. Time of contact for which force was acting. Okay. So if we say, let's suppose this thing is constant. So if I increase the time, if I increase this factor somehow, what will happen? This factor will decrease automatically to give the constant impulse, right? How we can take the example, let's suppose, for the sake of example, let's suppose impulse is, you say 10. Constant will be a number, right? It can be a 10 Newton second. And the force was, let's suppose, 5. So what should be multiplied with 5 to give you 10? It should be 2. Okay. So now let's suppose somehow मैंने क्या किया? I have increased the time. Now I have the time 4. So what should be the force to give the 10 answer? It should be 2.5 now. So that is again 10 Newton because impulse should be constant. So when the product, the final product, the final answer is constant, it's mean if you increase one thing, it will automatically decrease the second thing, right? So we have to increase the time duration for which the force is acting. If you stay static in front of a punch, तो होगा क्या? The moment the punch will be applied, the force will be applied, that duration is very short. But if you're moving, if you're riding along the punch, the time duration for the force to act will increase. Increasing time will decrease the force. That is the best way, right? There is another example for your better understanding. Let's suppose you're playing cricket and there is some ball that you have to catch. अच्छा, you have one choice कि आपके पास बॉल आ रहा है और अपना हाथ आप यहाँ पे स्टैटिक रखो. You are not going to move the hand, right? You will experience amount of force because of this ball, because this ball will have very high momentum. Why will it have high momentum? Because of it will have some mass, it will have some velocity, right? So this momentum will cause force on impact. That force is basically depending on the time as well, because force multiplied by time will tell you the impulse, and impulse is basically the change in momentum, right? There is a change in momentum. So how the momentum is changing? Because initially the ball is moving toward this side with some velocity, and at this point its velocity will become 0. So this is the final velocity, sorry, v. So there is some change in momentum. Change in momentum will define the impulse, and impulse is constant, right? So if impulse is constant, it depends, force depends on the time. If we increase the time, the force will decrease. So how I can increase the time duration for which the force is acting? How? By moving my hand like this. When you catch, आप यहाँ पे static नहीं रहोगे, बल्कि आप क्या करोगे? You will try to move along the motion of the ball, and gradually you will stop here. So इस point से यहाँ तक the force is acting. This is the time duration. it take the force, the velocity is not going to be zero at this point, right? It will be zero at this point. Why? Because let's take an example about that. Let's suppose there was some ball जो कि यहाँ पे था. Its velocity was, we can say it's uh, 10 meter per second, and it's going to fall here with some velocity. When it reaches its velocity will even more increase, right? It's 10 meter per second, 12 meter per second, let's say. It's 12 meter per second, right? Okay, so the velocity is 12 meter per second. It's not going to come to zero suddenly, but it will gradually reduce. It maybe because आप क्या कर रहे हो, अपना हाथ भी उसके साथ मूव कर रहे हो, तो मे इट विल टेक सम टाइम, अ ग्रेटर टाइम देन बिफोर, कि वो यहाँ तक आए और यहाँ पे उसकी वेलोसिटी क्या हो जाएगी, 0 मीटर पर सेकेंड. सो टाइम क्या हो गया, इंक्रीज्ड. Whereas in the previous case, if you are not moving your hand, जहाँ पे इस बॉल ने हिट किया आके, at the same moment what will happen, the velocity is going to become zero. At this point the velocity is, let's suppose, 12 meter per second, and at this point it will become 0 meter per second. So it's very short time. So when time is short, force will be large. In this case, time increase, force decrease. Impulse remain what? It remain, can you judge? It remain constant, because impulse is a product of force and time, and impulse is a change in momentum. Impulse is equals to change in momentum. Change in momentum is mv minus mu. In both the cases, final velocity, this thing is zero. Initial velocity will depend कि वो किस height से आ रहा है. तो in both the cases, the change in momentum is same, impulse is same, it's constant. We just can manipulate the force and time. How? By increasing this, by increasing time, we are decreasing force. And what will happen? This will reduce the chance of injury, right? So same application is used in the airbags as well. So this is the explanation. A cricket ball has very high momentum. So this is how it works usually in the field, right? So if you play cricket, you better know this phenomena. जो आपके विकेट कीपर्स होते हैं, गोल कीपर्स होते हैं, दे आर यूजिंग द सेम फिनोमेना, सेम साइंस. Okay, so this is the same phenomena. Application is